next we have problem 28. The function f of n is equal to a times n factorial plus b, where a and b are positive integers, is defined for all positive integers. If the range of f contains two numbers that differ by 20, what is the least possible value of f of 1? So what does it mean that the range of f contains two integers that differ by 20? That means that we can find x and y such that f of x minus f of y equals 20. And then substituting that into our function, this becomes a times x factorial plus b minus a times y factorial plus b equals 20. The b's cancel, so we have the a times x factorial minus y factorial equals 20. And now another important thing to note is that actually f of 1 equals a times 1 factorial plus b, which equals a plus b. And b can actually be anything, as we've seen. We're not really constrained. There's literally no constraint on b other than that it's positive. So we can just let b be 1. And then so we're trying to minimize a plus 1, which means that we're just trying to minimize a. So we're trying to minimize this. So that means we're trying to maximize this. But a still has to be an integer, so we still have to have the x factorial minus y factorial divides 20. And so now let's write out a list of factorials. So 1 factorial is 1, 2 factorial is 2, 3 factorial is 6, 4 factorial is 24, and 5 factorial is 120. At this point, all of the gaps are going to be way too big. And so yeah, now we're going to find x factorial minus y factorial that divide 20. So can we have x factorial minus y factorial equal 20? No, unfortunately not. What about x factorial minus y factorial equals 10? Also impossible. Third largest would be x factorial minus y factorial equals 5. And that's actually possible. So we take x factorial minus y factorial equals 5. 3 factorial minus 1 factorial equals 5. So we have that a times 6 minus 1 equals 20, which means that a equals 4. And so f of 1 equals 5. And just to verify, f of n equals 4 times n factorial plus 1 works because f of 1 equals 5 and f of 3 equals 25. And so yeah, f of 1 equals 5 is our least possible value of f of 1. It's a cool problem. This is something called a functional equation, which becomes a lot more common later on. For example, on USIMO and JMO, it's a fairly common type of problem to show up, where this one's a lot more constrained because all you have to do is choose A and B can just be, there's no conditions on B, so you can just let B be 1. And then you just have some conditions on A. It's a bit weird to think about functional equations at first because you're trying to find the function that works. It's weird, but with experience, it gets easier.